Hi everyone, we are going to talk about using slope to graph equations of the line and the linear models. So to start off, just some quick review. I would like you guys to try to do example 1 and 2 because they are just the basic graphing. Jog your memory. So pause your video, try to do them, and then come back and check and see do you have the same answer like mine. Here's the answers for example 1. The slope is negative 2 over 3 and y-intercept is 0, 3. So I start off with a 0, 3 and then I go down by 2 because that's a slope. Go down 2 to the right 5. Go down 2 to the right 5 to get my third point. So that will be the line for example 1. And example number 2, I wrote it out for you guys. The equation is in slope intercept form, and so therefore the slope is going to be negative 3 over 4, and the y-intercept form is 4. Now, recognize that m is negative 3 over 4 can be negative 3 over 4, positive 4. That means to the left 3 and to up by 4. Or you can do up 3 and to the left 4. So it depends on how your paper is situated. You can pick whatever the one you want works better for you. So I start off with 4, which is that's my y-intercept. Then I just did down 3 to the right 4. And that's how I get the next point and the point after. And I connect the point, and that's my line. I hope you guys have the same line like mine. So I draw the triangle for example number 4 for you, so maybe you can see it a little bit better. That's probably usually the best approach. Now you say, but Miss Wilson, sometimes I cannot see which line to draw. Usually go straight down, and if in the iPad, it's really nice because if your line is not drawn straight, it kind of jumps, and then so it's not going to come out straight. So that makes it easier to see which one is up and down straight. So hopefully that will help. But if there's a quiz, probably will be a little bit more clear than this. Okay, so now in this case, if you draw the triangle, you should see there's one and there's one dot and there's one not a dot. So a couple ways you can do it. You can go down, 2, 1, 2, 3, or you can go up 2 and go up 2, so be right here, 1, 2, 3. Okay, sorry, the drawing is not the best. Notice I also kind of changed the direction of it, so I can totally see that. So because of that, that's going to be either down 2 over to the right 3, or that's going to be up 2 over to the left by 3. So the answer really come out to be negative 2 over 3. And then after that, what you're going to do is you're going to write the equation of the line again, and that is going to be y equals mx plus b, because that's your y-intercept and your slope, and that's your b, and that is m. Okay, and then so in this case, when you plug everything in, it's going to be y equals negative 2 over 3. That's your m, x plus b. In this case, it's negative 1. All right, so the way we simplify negative 2 over 3x minus 1. And if you don't want to write the first step with a parenthesis in it, it's okay. I totally understand that. On to example number 5. Now, this is where we're going to be using, so taking what we learned before, and we're going to put it in the word problem. And we kind of done this already a little bit before we went on the Christmas break. So hopefully this will jog your memory one more time. All right. So example of number 5 says the percentage of U.S. food sales that are organic products aren't shown. So there's your table, okay? And then there's the year and there's a percent. So let's read through it. The percentage of U.S. food sales that are organic products are shown in table 27 for various years. Let P be the percentage of U.S. food sales that are organic product at T years since 2000. 2000. That is a very important information right there. Since 2000. A reasonable model is P equals 0.3t plus 1.1. And this is also something we did before. So let's just do a quick jog your memory kind of stuff. Okay, so first of all, year since 2000 means, if you look at the chart, the very one is 2000. So therefore, we are going to start that as a 0. Okay, because that's 0, that's at 1.2. When you have 2, that's 1.6 because it starts at 2000. Okay, 2000 starting is 0. And then 2, this is 4, this is 6, this is 8, and this is 10. And that is your table. So now what we're going to do is we are going to take the year and the percent to put it on a graph. They want you to hand graph it. So now you guys should understand year is explanatory. That is X, that's independent, and percent is the responsive. So that should be your Y. That should be your dependent variable. So you should also understand year should go on the bottom. So here's my years. Okay, and that's going to start with 0. I'm going to do it right here. But because it gets too crowded, I'm going to try to go by 2 so you can see. So 2, 4, 6, 8, 10, 12, 14, 16. Okay, and then that's your years, and that's your time. Then right here, this is going to be your percent. And I am going to go up 1. That's going to be 1. Okay, and then because that's 1, it gets really small. So what I'm going to do is I'm going to just go up by 2 so you guys can see it better. So that's going to be 2, 4, 6, 8, 10, and so forth. So now I want you guys just pause the video and plot the points on the table from the left and onto this graph. Okay, so in this case, to graph the model. Now to graph the model, that's actually the equations that gave you. That's your model. So in this case, this is the table they give you. So at 2010, they have 4.0. But you kind of go, yeah, Miss Wiesman, it's supposed to be 1.1. Where did the 4 come from? So let's plug it in a little bit just to be sure. Now, we can definitely say if we are at 2000, that's a 0. And it starts at, if you plug in P, which is the product that you're going to have, P equals, if you start at 2000, that's 0. That's going to be 0.3 times 0 plus 1.1. And that's going to be 1.1 at 2000. Now take a look. What do they have at 2000? 2000 is 1.2. All right? So it's not exact like what the models say, but it's very close. So let's take a look at 2010, just because those numbers are easy to see. So if you put in 2010, that's really 10 years. That's going to be 0.3 times 10 plus 1.1. And that's really 3 plus 1.1. Ah, that's really 4.1. It's not really 4.0 like what they say here. See that? They're not the same. Okay, so it's very clear, but it's not exactly the same thing. So now what happened is if they want you to predict a reasonable, what we're going to do. For the second part, predict when 6.2% of food sales will be organic products. Do you have much faith in the prediction? Well, since it's really close, I will probably say yes. My prediction probably should be really good. Now, couple things. They might have you predict by extending the line or using the model. But using the model is easier. It's close enough to it. So what we're going to do is we're going to say 6.2% is just like the 1.2%. So in this case, the percent is going to be the P, and then we're going to just ditch the percentage symbol. So that's going to be 6. Let me write the formula down. That's going to be P equals 0.3 T plus 1.1. So now what you're going to have is you are going to say, hey, if P is 6.2, that's going to be 0.3 T plus 1.1. And you guys should all know how to solve for T. So pause your video, finish solving it, and then I will give you the answer. So it says in 2017, 6.2% of food sales will be organic products. Do we have faith? Well, based on the equation, yeah, it's pretty much similar. Okay, but the problem is there's so many technology, so many different kind of things could happen. We never know what will happen even just 1 year down the line. So do you have any faith? Yes, based on the information, but no in reality. Does that make sense? Do you have much faith in the prediction? Not really. But because anything can happen. I hope that explained your this word problem. Okay, and we're gonna practice a few more so you get a better understanding of it. Example number 6. In 2010, a college's enrollment was 20,000 students. Each year, the enrollment increased by 2,000 students for the period 2010 through 2015. Let E be the enrollment in thousands of students at T years since 2010. There's a couple pieces of information is very important that they discuss. First of all, each year the enrollment increased by 2,000 right here. Each. It's very important. Okay, and then the next one is for the period of 2010-2015, but like E be the enrollment and T since 2010. That's also important. Okay, so now two things you have to keep in mind that the increase enrollment is increasing at the same pace. So if you look at here, that's plus 2,000 students every year. Okay, and then this is going up by 1. Now, if you remember from previous things we talked about, we said if the enrollment is a consistent increasing per year, then you should know something. So here we go. The first question. 1. Is there an exact linear association between T and E? Yes, there is a exact linear association. The reason for that is because every year it increases the same enrollment number because they are the same. The exact linear association between two variables is totally going to happen. All right, so let's write that down. So this is what I said. Since the rate of change of enrollment per year is constant, 2,000 students per year, the variables t and e are exactly linear association. All right. Now, what happened here is another thing you can think about. Since we know this is the x and this is the y, that t is the independent variable and y is the dependent variable. And if you think about it, the slope is y over x. And then if you think about it, that's 2 over 1. And it's always 2 over 1 and 2 over 1 because your slope is the consistent number every single time. And therefore, it's also the exact linear association. All right? I hope that helps. The next, number 2 in example 6 is find the e-intercept. Now think about it. I just told you guys the y is the intercept. That's the e part. Okay, find the e-intercept of a linear model. What does it mean in this situation? So it's really, if you think about it, in year 0 and the 20 is going to be your y-intercept in this case, but they use the word as e. Okay, now what that means is the e-intercept is 0, 20. I should say this is, let me rewrite that. Okay, now what does it mean? Well, it means the enrollment, well, because that is how many students, right? The enrollment is at 20,000 students in the year 2010. So we pretty much just say whatever the unit is for 20. If you look at it, 20 is right here. And what's 20? Enrollment in thousands of students. And what's right here matches up. Now you have to pick 0 because that's a 0 number is going to be the y-intercept. So 0 at the year since 2010. So 2010 is going to be at your 0 hours. So what happened is, let me write this out and then you can see a little bit better. Okay, so number 3, find the slope of a linear model. What does it mean in this situation? The rate of change of enrollment is 2,000 students per year. Same thing from what I said before, you just add the units. The slope of a linear model is 2, which is we talked about it before, right here. Okay, and that is the 2 things you need. So first you got the e-intercept, which is your y-intercept. Then you got the slope, okay? So now the next thing they want you to do is find an equation of the linear model. So you know your e-intercept is 0, 20. And then your slope is 2. So again, using the slope-intercept form equation, you are actually going to have y equals mx plus b, because that's the 2 pieces of information you have. And so therefore, your equation is going to be E equal to slope 2t, because that's your x, plus 20. 20 stand for 20,000 students enrollment at the very beginning. 2t, the 2 stand for every 2,000 students enrolled per year. And E is going to be the total student that is there. Okay, on to example number 7. Example number 7. The temperature at which water boils, the boiling point, is explained by elevation. The higher you are, the lower the boiling point will be. At sea level, level means 0, the water boils at 212 Fahrenheit. The boiling point declined by 5.9 degrees per each 1,000 meter increase in elevation. And this is from. So here's the words I put down. Rate of change is a consistent negative 5.9 degree Fahrenheit per 1,000 meter. So in this case, we are going to say yes, it's exactly linearly associated, and the slope is negative 5.9 degree Fahrenheit over 1,000 meter. So we can just write it down as negative 5.9. Negative 5.9 over 1, and that's really just negative 5.9. So I want to put those in the proper form for you so you can see they are all related. All right, so now what you're going to do is they want you to find the equation of the model. Well, the equation of models is you have to understand I need to have two things. One of them is my slope. The other one is at what's my y-intercept. Well, in this case, the y-intercept, they told you that at sea level with elevation at 0, the water boils at that. And therefore, that is your y-intercept. So I will put that down for you, and then you guys can see. Okay, so for the purpose, y-intercept is 0 and 212 degrees. But to fit into this problem, the B is the boiling point. So at the very 0, when time starts at 0, okay, or sea level equals 0. So what happened is that's also your B-intercept. So for the equation, it's going to be B equals negative 5.9, that's the rate of change, E, the elevation, that's plus 212 degrees. Okay, and that's the equation of the model. The model is what is the situation, the equation for the situation. That's what a model means. All right, on to the next question. Next question says, Mount Kinsley, the fight mountain in the United States, reaches 6.194 thousand meters. Predict the boiling point of the water at the peak. So what you need to do is you need to understand what is this 6.94 thousand meter means. Is that the B or is that the E? Well, E is stand for elevation up here. So E is stand for the elevation. All right, so we are going to plug in to the equation we have before. Simple as that. So B, that means the boiling point, equals negative 5.9 times 6.194. 6.194. All right, and then plus 212. And when you work it out, that's about 175.46 degrees. That means when the boiling point at 6.194 thousand meters is at 175.46 degrees. Okay, so that's that. Now again, there's a little graph. So graph the model. You don't have to graph the model. Okay, if you can answer the question, that is something we can always done in calculator also. So that is the question. Example 8. Worldwide jewelry sales are shown in Table 29. For various years, let S be an annual jewelry sales in billions of dollars at T years since 2000. Again, think about your information. A model of situation is S equals 26T minus 38. So they give you the model this time. Now think about what is 26 stand for. Think about what is negative 38 stand for. Okay? And since year 2000, that is also important. Okay? Alright, so now use a TI-84 to draw a scatter plot and the model in the same view window. Check whether the line comes close to the data point. I'm going to stop this and then do all this and then take a snapshot and show it to you guys. Hi guys, I also want to maybe review some of the graphing and everything else, but couple things before we even start entering the lists. I would like you guys to remember, since this is year 2000, that means year when you enter is going to be 9, 10, 11, 12, 13. And the sales is just the way it is. Now, when you enter into the calculator, you need to make sure that you enter into list 1 or 2, or you need to make sure that when you change the entering list, you need to make sure that you have the correct list number. So just in case, I will also run through that with you guys. And when you enter it, so when you do this entering stuff, entering list, you need to do a couple things. So what we're going to do is we are going to go to stat, okay, and then we are going to type 1 for edit. Now I just go in here and add in all my lists. Now notice I put in 9 and 10 and 11 and 12 and 13. So I didn't put in 2010. Okay, so then I enter the other list in the list 2. Then what you're going to do is you can quit out of it. Now, couple other things, making sure you are turning it on, because if you just switch the calculator, you are going to have things that you are not 100% sure. So what you have to do is make sure you turn on the scatter plot. Now, very important, scatter plot has to be turned on, and you are drawing picture from L1 to L2. Now previously I made mistake, and then it gave me the mistake of invalid dim. Now because I have set in list 3 and 4, so you can definitely go in and change your list. Now to change your list, what you can do is you can just type 1, and since the first one is scatter plot, we're going to leave it like that. And right here is list 1 and list 2. So if you don't have the correct list, make sure you have the correct list. And make sure it turns on and press enter. Okay, a second quit. Now, if you want to graph that, you have to go to zoom and to 9 and to do zoom stat. And you have the dots. Now the line is there is because they want you to put them together, and the way you do it is you go to y equal, and then you type in 26x. Even though they use t, in this case is x, okay, and the y is going to stand for the s. So that's what I type in, and when I type graph, it will give me that line. All right, so if you look at it, this is really, really close. And then what you have to do is you also have to do one more thing for me. And this is called finding the R. This is the correlation. All right, to find correlation, what you have to do is you are going to do, see the catalog? You're going to go to second catalog. And then I'm just showing you ahead of time because eventually we are going to use this. We are going to scroll down to diagnostic. Okay, diagnostic has to be turned on. See that? On and off diagnostic. Now, when you turn on diagnostic, this is how you do it. Press button and say diagnostic on, and then you press enter again. And it will tell you it's done. Okay? And then, for now, that's what you need to do. And you should be able to get this picture of Zoom 9, and then your line graphing it. And if I would say that's pretty close association, correlation is good. And it's a positive linear association, close to it. Okay? And then we're going to put that in the paper. So based off the graph we just did, yes, it's very close to the data point. And number 2, what is the slope of the model? Well, the slope in this case is 26. And what does that mean? Well, that means slope. And that means the worldwide jewelry sales increased by approximately $26 billion per year. Let me write that down because, guys, remember, it's going to be this sales over years. Okay? So, sales over years. So, let me write that down for you. So here it is. This means the worldwide jewelry sales increased by approximately 26 billion per year. That's number 2. And the slope is 26. Okay. So number 3, find the rate of change in the sales from 1 year in table 29 to the next one listed. So the change is going to be right here. If you do the subtraction, this is going to be 1 year, okay, and this is going to be about 12. So the rate of change from 2009 to 2010 is about $12 billion per year. The rate of change from 2009 to 2010 is right here. Here's your rate of change, $12 billion per year. Okay, next question. What is the S-intercept mean? Well, let's think about it. S-intercept is when they start at year 0 because that's your X. And that is going to be trying to figure out, that means 0, negative 38. Now, how do you have negative 38, Ms. Wiesman? Well, remember your equation is S equals 26t minus 38. And then therefore, the negative 38 is your y-intercept or s-intercept. And what does that mean? That means, according to the model, the jewelry sales were negative $38 billion in 2000. That's what that means, okay? And then that is going to be 0, comma, negative 38. And let me write that down. So again, the answer, according to the model, here's the model, S equals 26 minus 38. Jewelry sales were negative $38 billion in 2000. Now, I also want you to keep in mind, this will be your slope. 26 is your slope. All right, that means it went up $26 billion per year. Okay, so the next one, estimate the sales in 2013. Now, 2013 is the first thing you need to realize. That means since 2000. So your T, which is year, should be T equals 13. And then you need to plug into your equation. And so that's going to be S equals 26 times 13, because that's T, minus 38. And then when you do that and we'll solve it, 26 times 13 is, and minus 38 is going to be 300. Okay, and then what you're going to do is you are going to answer the question. And what that means is, according to the model, because it's the model that we are based off our answers off of. According to the model, the worldwide jewelry sales were $300 billion in 2013. So let me write it down. So here's number 5. Estimate the sales in 2013. You use the same equation. You plug in the 13 minus to 2000. So that's 2013 minus the 2000. I give you 13 years because that's where it started. It's 300. So in words, according to the model, the worldwide jewelry sales were $300 billion in 2013. And that concludes our lessons for 7.3. And pretty much it's based on the things you know, but now it's applying to the word problems. If you have any question, please ask me. Thank you so much for watching.